In this lesson, we're going to be talking about equations where the variable that you're solving for is in the denominator of a fraction. So let's take a look at this first example here and kind of talk about the steps on how to solve these types of problems. So in this first example, you might be looking at the -4, because in a regular two-step equation, you would want to get rid of that -4 first, right? You wouldn't want to start working with that 6 quite yet. So you're exactly right. Let's go ahead and eliminate that 4. So I'm going to go ahead and use my skills of solving an equation, and I'm going to go ahead and add 4 to both sides. That's going to leave me with 6 over x is equal to -6. Okay, at this point, there are two routes that you can go for this one, and I'm going to show you both of them. The first route is by moving the x out of the denominator. And the way that you do that is you simply multiply both sides by that number x, or that variable x in our case. What that does is it eliminates it from the denominator, and it leaves you with 6 is equal to -6x. And it's just a regular equation that you can go ahead and solve at this point by dividing both sides by -6. So x will leave you with -1. So that's one way to solve this. Now, let's say, I'm going to go ahead and grab a different color pen just to kind of show you this. But let's say that we are going to leave off at this location here. So I'm just going to rewrite it as 6 over x is equal to -6. And instead of going the route that I did, let's say that I want to set up a proportion. Now, didn't we talk about any number can be placed over 1? So couldn't I place that -6 over a 1 and it creates a proportion? And then what I'll do from there is I'll use my cross products. So I can do that to set up my problem. So let's do that. -6x is equal to 6 times 1. And I can go ahead and solve that problem. And you can see that by solving this, it's still going to give me the same solution of -1. So two different ways you can do it. Technically, you're doing the exact same thing. It's just the procedure is slightly different. Okay, let's go ahead and look at another example. I have lots of examples here because this concept does get a little bit challenging as we get to a little bit of the harder ones. Okay, in this next example, let's go ahead and let's take a look at this. It looks a little bit different this time. The first thing that comes to my mind to do with this problem is to put common things together. You can see that 1/3 and 2/3 are both constant numbers, meaning they don't have a variable with them. So don't you think we could put those together? I'm going to go ahead and try that. I'm just going to go ahead and I'm going to move 1/3 over to the other side. By doing that, it eliminates it on the left-hand side, and I'm left with 3 over x is equal to 1/3. And see what it did? It created a proportion for us to solve. So now let's go ahead and do our cross products. A nice simple problem to work with. So we have x times 1, which is x, and then 3 times 3. I'll write that out. 3 times 3, which is 9. So in our case, our x is going to equal 9. So it really wasn't that hard in this case, but it all worked out. All right, let's go ahead and bump it up just a little bit. Now let's take a look at this problem. This problem's a little bit different. And what makes these types of problems a little bit more challenging is that there's not really one procedure to do for all of these. You really just got to think about what you're trying to accomplish in the problems. So let's go ahead and solve for the x. Notice that I have an x in the first ratio and in the second. So in this one, it makes my brain kind of go towards the idea of creating a common denominator, doesn't it? So couldn't I make a common denominator of 2x? Let's go ahead and do that. I'm going to make my common denominator because all I'm doing is adding fractions, right? And when we add fractions, all we need to do is make a common denominator. So it works the same way here. In the first fraction, I didn't change it, so I'm not going to change my numerator either. But in the second problem, I multiplied it by 2, right? So I'm going to multiply the numerator by 2 as well. And 2 times 4 is going to give me 8. And I'm going to set that equal to 13. All right, now that I have a common denominator, I'm going to go ahead and add those fractions just like I would a regular fraction. That's going to leave me with 13 divided by 2x equals 13. And there we go. Now that we have this, we can go either way like we did in number 1. I'm going to go both ways just so you can see the difference between the two. But I need to get rid of that. I need to get that x by itself. So let's first go ahead and get it out of the denominator. So I'm going to multiply it by 2x. Okay? And so that eliminates it from the denominator, and it leaves me with 13 equals 26x. And then, of course, I'll just go ahead and I'll divide it by 26, and that will give me x is equal to 1/2. Okay, so that's one way to do it, just like we talked about in number 1. But let's go ahead and let's take that same problem that we got to, and I'm going to show you the other way. So 13 over 2x is equal to 13. And let's go ahead and do it the other way. Let's go ahead and make it a proportion. Let's put it over 1. Now we can go ahead and multiply those cross products. So either way that you'd like to do it is up to you. So I have 2x times 13, and that's going to be equal to 13 times 1. So that's going to be 26x is equal to 13. And just like before, I'm going to divide both sides by 26 to give me x is 1/2. So either way you do it, you're going to get the same answer. It's just a matter of which way do you prefer going. All right, I do have one more example here for you. And it looks a little bit different, as you can see. But you can see that I have variables on the left and on the right. So in my head, I think we'll put them together, right? Let's put them together before we do anything else. So what I'm going to do is I'm going to go ahead and subtract 1/2 x from both sides, just to move them over, get rid of them on the left-hand side. That leaves me with 3 over 10 equals, and I'm going to write this out so I can show this to you. 1/5 x minus 1 over 2x. Okay. Now, all I'm simply doing is subtracting fractions, right? So I could do that right in my calculator, 1/5 minus 1/2. That's all I need to do. Or you can spend some time finding the common denominators and subtracting by hand. Either one is fine with me. But of course, that's going to leave us with negative 3 over 10x. Because when we do that 1/5 and we subtract that 1/2 from it, that's going to give us negative 3/10. So now, as you can see, we have a proportion. So let's go ahead and use our cross products and solve it. So I'm going to do, let's do 3 times 10x is equal to 10 times negative 3. And simplify that down to 30x, and that equals negative 30. And I'm going to divide both sides by 30 to give me x is equal to negative 1. And you're done. So it's just a matter of working with that denominator and making those denominators the same, and then working with fractions. That's really basically it with this concept. But what's really cool about this is taking that concept of proportions and using that to help us answer these types of problems.